This is the fastest gaming CPU on the planet right now, installed in an $1,100 ROG motherboard. But you know what? It's just not fast enough for me. We need to go faster. So today, we're gonna be taking Intel's Core i9-12900K, putting a healthy little dollop of dielectric grease all in the CPU pins there. No, don't worry, this is for its own good. And we are gonna be taking it sub-zero with our 3,000 watt CPU chiller. That's right, we're hooking an air conditioner directly up to the CPU socket, and it's gonna be a lot of fun, ladies and gentlemen. Let's see how fast we can make this thing go. And who's sponsoring this mess?
Seasonic.
Oh, that makes sense. They'll sponsor anything.
What? 1,300 watt power supply?
Oh yeah, I guess it kind of makes sense in this case.
Yeah, it makes loads of sense.
You try and do stuff like this without a good quality power supply, you're gonna have a real bad time. Go check out Seasonic, linked down below. You guys did your best on the installation job for part 1 here.
No, we didn't.
But I'm definitely glad that I'm here to supervise this time. Here's the thing. When I said that I was doing this for the CPU's own good, that's the truth. The goop that I'm sticking into the pins in the CPU socket here is called dielectric grease, and it serves a very important function because while the chiller project was an enormous success, we managed to get this Core i7, this is an older one, down to minus 20 degrees Celsius. There are some inherent risks that come with going that cold, namely condensation. So because you can't stick, a big old thing of foam into your CPU socket pins, you want to use a non-conductive grease like this dielectric grease that I'm smearing around in here to make sure that we don't have any moisture causing a short between the pins. That would be a real bad time and probably kill our CPU. Something to note, guys, is that as messy and awful as this looks, it's not harming the motherboard in any way, and this board could continue to function for years with this dielectric grease in the socket. It'll just be messy. It'll be a messy boy. Give me more, free Britney more. It should be criminal to have this much fun at work. It's hilarious. Now, normally at this stage, we would install the CPU and use the hold down and retention arm to keep it in place. But when you're going sub-zero, you can't afford to have any little air gaps around the CPU because that's where all the cold refrigerant is going to be delivered. And the thing is, something like this, absolutely impossible to perfectly insulate. So you're gonna get these little pockets where you get moisture condensing on the cold metal and then dripping. Is it possible to both hate and love something this much?
Clearly.
Yeah, because I'm doing it.
Jeez.
My fingers are greasy. It's probably fine.
Yeah, it's pretty shielded.
Oh yeah, it's actually got a whole plate on the back and everything. Wow, it's Linus proof. This is a disaster. Why did you guys do this? Is there another one?
Yep.
All right, thank goodness.
Yeah, that one was already pretty shot.
The good news is that we aren't going to do anything like that to it this time because you don't really have to. This is a cool feature of this board, by the way. It has not only the LGA 1700 holes, which are standard, but it also has the older style LGA 1000 series holes. So when you've got an old cooler, you can just put it on there. Get on there, little buddy. How much frost did you guys get on the back of the board last time?
Outside of that pad.
Outside of that pad?
Yeah.
Then the back plate's coming off. I wish I hadn't put the dielectric grease in just yet, but hey, that's what life is about, learning through my mistakes. The good news is that none of this stuff that's got a thermal pad on it on the back here is gonna need to be cooled. I should probably explain that. PCBs, or boards like this, are made predominantly of copper. So copper happens to be an excellent conductor of heat, which means that if you cool this CPU socket area, it will actually cool a huge amount of the board around it, especially when the CPU isn't working real hard, because there's just not enough heat from these surrounding components to overcome the frost spread. Now, they apparently didn't find this when they were insulating last time around, but I actually have a motherboard sized and with all the holes already punched through it, piece of this insulation foam here. Then I'm gonna take the part for the CPU, I'm gonna put it right there, And we're gonna stab all the way through, and that should pretty much do it for insulation for the back of the board. So where are the stabbies?
Over there.
Okay. How many of them are through?
All of them.
Oh, they're all through?
Yep.
Oh, nailed it. I think you might be mistaken though. I think it might be the outer one. It doesn't matter though. It doesn't make a difference to what we're doing. I mean, we could just use the threads to kind of
Oh no.
eliminate the gap between them. This is a trippy kind of eraser that I had actually never heard of in my life until I tried to sub-zero cool a machine a few years back and learned that you put it down on the paper and then lift it up. You don't like rub with it. Anyway, it's super malleable and it's a nice cheap way to insulate around a CPU socket. So this allows us to kind of push into little gaps that we otherwise wouldn't be able to properly protect. This is more for if you wanted to daily drive sub-zero cooling, which by the way, people used to do back in the day. Like there was a huge small community at Extreme Systems and stuff like that would build custom phase change coolers and actually 24/7 their CPUs at sub-zero. You always need to make sure that you're focusing your insulation on places where you could potentially have moisture drip. So I'm gonna make sure that I pack things in really good down around the bottom here. God, it's been so long since I've insulated a board. Feels good, feels nostalgic. Back when overclocking was fun, Maybe if I just will it to be fun and have a point again, it will. We wanna go right up to the RAM slots, because the last thing you want, man. I can't think of anything you want less than moisture in your RAM slot.
Metal chips.
I mean, yeah, metal chips, okay. I mean, it's not a competition, Alex. Now what we need is to get our insulation up to the same level as the IHS of the CPU, so the top of the metal spreader. And we're gonna use this for that. It doesn't have to be the most crazy precise thing in the world. What's nice about sticking this stuff onto the artist eraser is that you can actually clean up the board reasonably well when you're done.
You know what's another way to get no air in there?
Put it in a vacuum sealed container. No, I refuse. It's awful, Alex. I will not do that to this board. Not perfect, not bad. Now we need to this-ify this. Now, do you want this thermal probe in there?
Yeah, we need the thermal probe in there.
So we're gonna go right there. We're gonna kind of force it into this crack. I wanna get this probe covered. Oh, hold on, I lost the thermal loop. Okay, right there, yep. This is why I wanted it to be round, by the way.
I know.
I know that it wasn't possible. Okay, so now we just have to get it down to the level of the cold plate. Like you probably need a solid 3 layers of this stuff over every part of it. Do you wanna wrap that for me, please?
Oh yeah, the adhesive on this isn't very good.
No, it's really worn out. This is super old. Is there an orientation? Does it matter?
No.
Okay. Oh my God. Honestly, this is not that stupid. I'm serious. It's really not. So you'll want to do another round of that. And then don't bother trying to poke holes or cut it perfectly. Just put it on and just poke it through the hardware. And then tighten down the hardware just right on top of it. Just make sure you've got a pretty decent amount of pressure.
All right.
This is going to work.
Now just more insulation and hopefully we're good to go. Now we want this tight, but not super duper tight, but also pretty super duper tight because it is holding in the CPU. Now, last time we had some issues with these lines also getting all frozen and condensation-y. So with any luck, this will help prevent that. Ugh, that's really on there. Frickin' heck yeah. Should be so much better than last time.
Yeah.
Yeah.
Yeah. I mean, that's pretty fine, I think. Where's our GPU at? I like it, I like it. High enough performance that our benchmark scores will still be good and not bottlenecked, but we're not risking anything too expensive. Got a 3060 going here. You know what's the craziest thing about this chiller? Is that it is conceivable that we could actually hook a GPU up to it as well in the future, just with like a splitter or something like that off here.
Yeah, it won't go a whole lot colder. Like you'll be able to see the condenser temps right here, but it can definitely pull a lot more heat out of stuff.
Yeah, it'll be really nice to have just like a ready to go sub-zero cooling solution, just like that. Oh, our RAM is gone.
Oh yeah, that's pretty important.
I don't want to lose that DDR5 RAM.
This stuff's expensive as frig, isn't it?
Yes. Oh yeah, this is the 6000 CL36 stuff. This stuff better not die. I mean, that's okay. G-Skill, you'd forgive us, right? G-Skill watching, like. I'm so damn excited right now. Are you ready?
Sure, should we make sure this turns on first?
Oh yeah, right. If we were daily driving the thing, normally people set up a relay so that when you press the power button on your computer, it also fires up your compressor and your fan for the condenser, but no, we don't have that, so yeah, go ahead. Never do this. This is mains power, never this.
Yeah, none of this.
None of this. The only reason we have it still connected at all is because you can't just plug in a modern compressor and condenser and expect it to just run full tilt all the time. And you wouldn't even necessarily want it to. That wouldn't be healthy for it. So this is the controller that has all the safeties, like say, for example, the safety that turns it off if the evaporator fan turns off, which is why we have this sitting here spinning. Oh, I'm gonna let go of that. All right.
Yeah, let's turn this on.
Fire it up.
Come on. Okay, we'll see if it starts. We might need to warm this thermal probe up a bit. There we go. There we go, the fan's spinning.
I really hope it posts. Especially after I lectured you guys about your way of insulating. If my way doesn't work better, then I'm gonna look like a jackass.
Oh, it's officially sub-zero.
Nice. Come on, baby. Oh, I see flashing on the thing.
There we go.
Yes! Okay, that's step one.
Step 2 is ignore fan monitoring.
Oh yeah, we
CPU.
don't need that. These are already frosting. Definitely need to cover these up. You see what I'm doing here, Brandon? I'm just covering up that exposed metal from the bolt through. Brandon, there's a little display on this ridiculously fancy motherboard. If you come over to where I am, you can see it's gonna pop up CPU package 0 degrees. There it is. It could very well be lower, but that might be the limit of what it'll display.
Yeah, the radiator inlet's currently at 16.5 degrees, which is ambient, so we are not able to get any colder than, I guess, 14 right now. Negative 14.
Minus 14. Okay. Well, I mean, hey, that's not a bad start.
Yeah, it's not warm.
Yeah. Do we have any parts of it that are sort of scary cold and we're worried about condensation on?
Some of these bits around the top are very cold.
Like right here?
Yeah.
Okay. The good news is, at least to the touch, it feels not bad. What you would normally do, assuming you actually wanted to 24/7 this thing, is you would keep the computer off during this kind of testing, like where you're looking at temperatures and checking for condensation, because that way any moisture is not going to harm it. Then what you would do is you would make sure you'd run it for like 24 hours. Take it all apart, kind of go, okay, did we actually get any moisture pockets anywhere? And then if you didn't, then it's safe to fire up your phase change cooler and go to town. Because if it doesn't get condensation on it when there's no load on the CPU, it definitely won't when the CPU is generating some heat. And it looks like that worked. So we're turboing, which I guess we expected. CPU's like, oh yeah, I think I got some thermal headroom.
Yeah, I feel like if we just use ASUS's AI overclocking crap in the BIOS, we can probably get it going pretty fast real quick.
I sincerely doubt that it's related to the chiller right now. It's probably just this RAM being bleeding edge. Have we updated the BIOS of this board?
No, we haven't.
We should probably make sure we've got whatever the latest retail BIOS is as well. Brand new platforms, man. Stuff happens. That's why whenever you've seen us update our editing workstations, for example, I've seen criticism from people like, oh, you guys aren't even using the fastest stuff. I'm like, nah, dog. We go with something proven when we need to actually get work done. Gaming machine, sure, whatever. You get a blue screen once a month, who cares? But like, No, not when you're working. Task manager, just in case we need that for whatever reason. Okay, we are apparently at 0 degrees. Should we try putting a little load on it just to see what happens?
Sure.
Make sure that it doesn't freak out.
Our score to beat is 27,000.
Oh my God. Our CPU is running at 30 degrees on the package, running Cinebench. I think we've got a little bit of headroom.
Yeah, I think it's working.
So score, 26,866. Did we thermal velocity boost more than we did before?
No.
Okay, so it's basically the same?
Yeah.
Okay. Well, then it's time to turn up the juice. You just cranked it all the way to the right.
Yeah,
I mean, you can do whatever you want. It's a
we
free
should probably
country.
do like a 1/2 volt offset. That probably makes sense.
What is that even based on? You're just dragging sliders around.
Yeah, so, okay, what we're looking for is like 1.42, 1.43 volts. That'll get you like pretty fast on these.
Okay. So then we want about 0.25 then.
Yeah, that probably makes more sense.
Okay. Will not be able to recover to a valid state automatically. Hold on. Oh, Brendan didn't see that.
Yeah.
That was an amazing error message. Sorry you missed it. It basically said your system will not be able to recover to a valid state automatically. If this thing crashes, it's gonna crash. Let's see what happens if we actually put a load on it. 60 degrees now, 80. I think we have a thermal bottleneck, Alex. I think our interface,
We're also drawing 420 watts.
our interface is not good enough.
Nice boost though.
28,605. Well, it's faster. Let's run it again and let's have a look at our CPU frequencies. 5.2 on all performance cores and 4.0 on all efficiency cores. Why is it supposedly reaching 100 degrees and thermal throttling, but keeping that frequency the whole time?
Yeah, it's kind of weird. I would expect it to drop if it was actually that hot.
I wonder if it's not actually reading it properly. How high are these efficiency cores supposed to go? I haven't actually looked into this at all.
The highest that I've seen people get them is like 4.1, 4.2, but they'll do 4 pretty easily.
Well, let's go for 4.2.
Okay.
I mean, how many times do you live, right?
For this board, maybe once.
There they go.
It's doing it. Okay, so the core temperatures are saying that it's at 60 this time, despite it running faster. I think it was just bugged before.
29097?
That's really fast.
That's really fast. We are dangerously close to 32 core Threadripper 2990WX territory. We have half as many cores, guys. Half as many cores, boys. Okay, well, the only responsible thing to do at this point is to take our 2 active cores and see if we can do like 5.5.
You know what, let's just try plus 0.3 volts and see what happens. Yeah. I don't think our CPU is happy. I'm a little bit suspicious that our problem is current and it's going to cause our voltage to drop when we hit all of the cores at the 5.4, and that's why it's shutting down. We also might just be at where the silicon, like its absolute limits. But I feel like we can push it a little bit faster. Now, I have the multimeter hooked up to the pins here so we can see the core voltage on our multimeter. And I feel like when I hit go, it's going to go up to like 1.4 and then it's gonna drop and then the system's gonna crash. But let's see. The core temperatures are going fine. So it must have just been a problem with the reporting before when it said it was over 100 degrees. We drew 264 amps during that run, not bad. I think we need to leave XTU for a little bit and go into some real hardcore settings here. By hardcore settings, I mean just disabling all current limits. We'll just come in here. Oh, don't crash. Ah, damn it. You crashed. Oh, you piece of shit. We bring out the camera and this is what you do. Well, we beat the Threadripper. I guess it's not quite stable. I guess at the last 2 cores, we tried to get to 5.4 gigahertz. They're not very happy there. 5.3 seems to be where they want to be. The rest can do 5.4. But this is basically what we're doing. So for every CPU, you have your voltage and frequency curve. 4.5 gigahertz, you come over here, it's like 1.15 whatever volts is what you're getting. So first thing that we have to do is extend this. So it goes to like 5.2 right now. We want to go just kind of up here. And then we just offset the whole thing by what, 0.05 volts or something like that. Raise the whole thing up so hopefully it's more stable. Hopefully we don't get as much droop, although it's an insane amount of voltage this thing is taking right now. It's like over 400 watts. It's pretty stupid, but it seems to be working. I would very strongly recommend Scatterbench's Alder Lake overclocking guide. It's like an hour and a half long, but the amount of information in there is obscene. If you want to actually overclock these things, go and watch that. But anyway, all of the cores are at 5.4 gigahertz, except for the last two. They're at 5.3. They don't seem happy at 5.4. All of the efficiency cores are still at 4.2 gigahertz. And we're running what? Only 1.3 volts, although it does get higher than that, as you're going to be able to tell from here. So it's saying we're drawing 371 watts. Oh no. Why did we turn on the camera, Brandon? It was working before. Yeah. That's how it always works. 30,054 to beat, also not crashing to beat. Oh. 30,064. Heck yeah, beat it by 10 points. That's pretty crazy, given that we have literally half as many cores as the 2990WX. I'm getting slightly concerned. I can see that where the thumb screws are, there's a little bit of condensation. And if you look like over here, the amount of frost is obscene. This thing is so freaking cold. That gives you an idea of what it's like inside that CPU and why, if we didn't have all insulation, we'd be having a real bad time. Now let's come over here. I upped the voltage just a tiny bit. It's probably gonna crash. The second that we brought the camera out, it's just been Crash City, because of course it is. Yep. Piece of crap.
Did we get there?
We did, we beat it by 700 points, and then stupid Brandon had to turn his camera on. We can't do it again.
Oh, this is my fault.
Yes, this is your fault, Brandon. We did get it once on camera, but we only beat it by 10 points.
I think he meant stupid situation. Brandon had to turn his stupid camera on. It's not the Brandon that's stupid. It's everything else. Oh my gosh.
We did beat it. Like, look.
It's within 55 points on this run. You know what? I'm calling that a victory. I'm calling that a victory. It's obvious there's still work that we could do, whether it's on our evaporator design, whether it's on the flatness, whether it's on our mounting pressure, or whatever the case may be. But
I think also with just like,
this is a pretty cool setup.
We're in real like tweaking the littlest of voltages and frequencies and stuff. Like we're right on the edge.
In terms of if you've got an outstanding cooler, what to expect from Alder Lake, this is about it.
Yeah.
Just like you'd always expect me to tell you about our sponsor. What is there to say other than Seasonic? They make great power supplies that's right, can deliver 420 watts, nice, over the 8-pin CPU power connectors. And do it nice and stably so that you're not gonna be giving up any potential overclocking headroom because you got a crummy power supply. So go check them out. They've got up to 12-year warranties. Like what? And we've got them linked down below. Okay, let's shut it down and have a look at the nonsense. Ooh, okay, well there's definitely some frost.
Yeah, I was a bit concerned about those. I think everything else might be fine. So this all, there's a little bit of moisture right in here, right around the CPU. The rest seems dry. This also is all dry. That worked fantastic. Back of the motherboard. Oh yeah, that's totally dry. Bone dry back there. This worked really well. I'm super stoked that we were able to get this processor faster than 2990WX. That's frigging insane. Huge thanks to Seasonic for sponsoring this video. And if you liked it, hit like, get subscribed, and you know what? Watch our Sub-Zero cooling build guide. It was years ago, but Linus did a full guide if you wanted to 24/7 a Sub-Zero build for some reason. Bye.